Hi, welcome to a new episode. This time I'm recording the intro before actual work has started. In this part I'm going to cover adding dynamic linking capabilities to dynamic loader that I've created in previous episode. So theoretical part is covered in my previous video. Today we are going straight to coding. So go get your favorite drink and let's go! I added a test target with the simplest possible module with imported symbols. The test seems different from the previous hello world with printed text. But there is significant difference. Invisible from the source code is that the new module imports the print function from the runtime system. So it contains only the main function. There is no libopencm3, no libc, and no other libraries inside. I started Yasld implementation by adding an environment. The environment class contains symbol entries, and it will be filled by a runtime system with addresses to symbols that can be imported by modules. Since it can be filled only during building, I created a template class. Of course, I need a way to search for symbol addresses. It doesn't need to be efficient, since resolving symbols is necessary only during module loading. Let's fill print address for my first test. The compilation failed because I forgot to add the robot test implementation. Then I had to find a way to convert any function address correctly. I found out that I need to add the correct deduction guide for the compiler to make my constructor usable. The function didn't help. But I wouldn't say I like the solution with additional necessary steps. It should be doable in the constructor. Reinterpret cast is not compile time evaluated, so I had to remove const expression. Let's fix issues in CMake. I just remembered that I need to add the module and correct mistakes in naming. The new module is working, but one important note is that the new module is not yet importing symbols. It still uses the solution from the previous video. It's time to remove libraries from the module, starting from libopencm3. Since I removed system stubs implementation, new lib is failing. So it's time to remove system libraries. I added a new target that contains flags for a non-standalone module. I know, I'm bad at naming. If you have a good name for a module that imports symbols from the external world, I will really appreciate that. The new target provides the same flags as the old one, but also adds no default libs to prevent linking standard libraries. But I forgot to import old flags. Let's pause for a few seconds. Look how smart nowadays compilers are. I use print, which only prints raw string, without any formatting. So the compiler replaced that call with just puts, which is more efficient if formatting is not needed. Anyway, building a shared module shouldn't crash with undefined references. Undefined is the same as imported. So I added the flag that ignores that error. And I got an error inside mkimage. Of course, mkimage must be updated. It's not supporting imported symbols yet. I had to remind myself what was going on inside mkimage script. It's been a while since I made it. Mainly, I must fix the symbol table building to add imported symbols. But it was late, so I decided to continue tomorrow. Yesterday I started adding support for imported symbols in Yasld, and I stuck on issue that relocations towards unsupported sections are errored. So today I will continue with fixing that issue and adding implementation inside mkimage to support imported symbols. And I decided to split that episode to more parts, and thanks to that I will create it faster. So this part will cover only interoperation between runtime system and executable run inside it. And in next episode I will add support for shared libraries. Let's continue. The section for undefined symbols makes no sense, so I set it to 0. I have print float in my module. It is because it was necessary to undefine that symbol for newly print, but it's unused for modules with imported environments. So let's fix that. The compiler generated a new PC relative relocation, which needs to be skipped. In the previous episode, I mentioned that I suspect there are no imported or exported relocations. Those are relocations towards the symbol table, so let's fix that naming. Enough for today. The code is compiling. The next day I started with a GDB session, checking out how the code execution looks like. Of course, I loaded symbols for the module. For sure I have some infinite loop, probably because I don't have an implementation in Yasld yet. Oh, I forgot one thing. Long calls flag is necessary to calculate addresses correctly. Now I have a valid symbol table relocation generated by the compiler. Let's implement support for that. Symbol table relocation contains a pointer to the symbol table entry. Since I replaced imported and exported relocations to a single set of symbol table relocations, I also had to update Yasld implementation. Then I moved to the implementation of support for symbol table relocations inside loader. But then I realized that it would be easier to process if the symbol table relocation contains an index of symbol table entry instead of offset. So I changed the implementation accordingly. Processing of symbol table relocation is relatively easy. I just need to find the symbol entry for the given relocation. Then find the address of the symbol provided by a runtime system. A fast cleanup of code. And of course I have to fill offset inside offset table for symbol table relocations. Let's create an interface for the environment to hide information about size. In the future, I will consider adding dynamically created environments. Then it's time to pass the environment to the loader. The method of searching symbols should also support imported symbols. A module with imported symbols has a small size. That's the advantage of reusing code. I tried out a new implementation, but failed to search the main symbol, which was really strange. Why does it search the main symbol? Oh, I need the correct order of imported and exported symbol tables. But I introduce a regression, and all tests are stuck in an infinite loop. Let's run it one by one. Even the simplest test is failing. Let's check inside GDB. I accidentally removed flux propagation, so I reproduce the issue from the last episode, when ARM code is generated instead of thumb. The first test was fixed, but others are still failing. The calculation of floating points goes to an infinite loop. I made a mistake in accessing the imported symbols table. If you look closely, the exported symbol table is also wrong, but I will find out that later. It still crashes, and issues are also reproducing for simple hello world printing. I told you I will find it. It crashed because bare metal application shouldn't exist, and my went outside of the scope, so I need to add while true at end of the program. All already existing tests are working, so let's implement new one. Now let's add a test that uses more imported symbols. Firstly, I tried to pass values via imported symbol of variable, but I wasn't able to achieve that, so later I changed it to imported function call. New test is getting values from runtime system via calling external function, and then calculates sum, also do some maths on that numbers, and my goal is to finally return value as a return value from module. I have an infinite loop, but I haven't updated the environment yet. Nevertheless, loader should fail on searching symbol, but it didn't. I added some prints to make debugging easier and to prove that I'm iterating symbols out of range. Since I was not able to figure out why the code is not working, I added one more print to show a comparison. It seems that I'm comparing the flash address with the RAM address. It's obviously wrong, since the symbol table is placed inside the flash memory. The reason for that bug was taking the address of the root element instead of the root element. Now it's much better. Loading module failed on lack of symbol. It would be wise to add a test for that situation. Let's continue with the test with more complex calculations. I added the IABI F2D symbol, but I don't know where it's declared, since it's an internal symbol for GCC to support floating points on devices without hardware floating point unit. So I declared it inside the test itself. I have noticed that the symbol index is wrong. I've printed it out in GDB. Yeah, it always places the last element. Now it's much better. You may notice that my symbol has such a strange name. It's due to the fact it's a C++ symbol, and C++ uses mangling for names. I tried if GCC can use type ID for types known in compile time, but it can't without RTTI or I misuse it. If you have an idea how to get manglet name from variable or function, let me know in comment. There is a successful run, so time to add test implementation. Time for a bit more complex C++ with classes and polymorphism. I added an interface. Internal implementation of that interface and external implementation provided by the runtime system. CXA pure virtual is internally called when a pure virtual function is called. That strange Z and W symbol is just the operator new with size. I used an online demangler to demangle those names. I put link in the description. In C++ there is no way to get the constructor's or destructor's address. It's forbidden by language. But the constructors and destructors may be implemented using simple functions that takes the pointer to the object as the first argument. I use self-name because this is a reserved keyword for C++. Basically, myself is exactly same as this used in C++ member function implementations. I had to find a way to use a better address resolver, but temporarily I disabled pedantic errors with Pragma. I'm trying to pass the std-string implementation to use it inside the module. But I'm stuck on the problem that std-string uses internal data. It's a local data private field, and I have no idea how to get it. So I changed std-string to std-string view for now, which is not using any internal data. I hope that the issue with private data members will be resolved with the implementation of shared libraries. But if not, I will have to find solution how to access internal private data members, also static private data members, from any object. Maybe I can use some linker output for that, but for now it's not a blocking problem, so let's leave it as it is. You may have noticed that I have two copies of the interface. inside module and inside host implementation. It's an evil practice, don't ever do that. I will pay bill in the future because I put that shitty code. Internal implementation works, but there is a crash with an external one. My create external implementation needs to be corrected. It should construct an object, not allocate it. So I use placement new for that purpose. It seems that self variable is incorrect. 4 is not valid pointer to RAM in that hardware. So I wrapped operator new to make debugging easier. I didn't know why, but make unique was not working. I replaced it with just a new call, and the issue with the external module was fixed. But then I noticed that destructors weren't printed out to the console, so I started an analysis of that case. It was quite long debugging session. I realized I can't skip symbol table relocations inside mkimage script. They must be processed to fix accesses after offset table changes, so I have to keep them all. I moved the skipped ones to a new set. They all should use the already allocated indexes. And it worked. So I started cleaning code from debug prints and from wrapping functions. Then I restored the version with make unique. I changed the implementation of the external class to actually do something. And there is the time when the duplicated interface is going to beat me. Allocation of objects was failing. I noticed under GDB that malloc internal structures were destroyed, and malloc is internally used by the operator new. And then I realized that I was doing some changes toward external implementation, but only on test side, and probably I haven't updated module. So the size of external implementation is different for test and different for module. For module its size is smaller, and due to that I'm overriding memory which is internal for malloc. I'm pretty sure that this is the issue here. So let's check if my theory is correct. I just need to open module for that, and let's see external module, external implementation. Yeah, exactly, I don't have fields here. I changed implementation to support name storing and values, but I haven't updated that class here. In practice, this should be separated header shared between module and tests, and probably I will do it till in this episode, because that's actually very bad habit to create more than one declaration of interface between components. Now it must work. Let's check it out. Yeah, exactly, that was the issue. Okay, so now it's time to implement real tests. So I need to write robot scripts, then I need to fix unit tests, and this episode is done. Since I fixed the last and worst issue, I started fixing unit tests and removing ones that are no longer needed. They were replaced with system tests. Then I extracted the interface to separated file to correctly resolve the issue that I encountered. And then I continued with cleaning code, CMakes, and fixing unit tests. And then I encountered the new issue. It looks like one entry in the load table has the address C. For sure it's invalid address, but it was correctly generated by the compiler. The issue here is that I'm passing the address of virtual function to symbol entry. When it's cast before passing, everything is fine. But when it's passed to function, the compiler instead of the real address passes offset in bytes to the virtual table entry. I spent a lot of time trying to make my function to get a real address, but I was not able to do that. So finally, I did exactly the same solution as for constructors, since taking the address of the virtual function may not be a wise solution. Yeah, now it's working fine. So I restored this implementation and did some cleaning. After a few hours of working, I implemented support for imported symbols. This is crucial for dynamic loading because I have to pass symbols between libraries and executables. So now I'm ready to implement full dynamic linker which will resolve symbols. Those symbols that I'm already passing from operating system or runtime system manually, declaring their names and addresses to the modules that using them. With dynamic linker, it will be linker responsibility to take addresses and symbols from one library that defines some functions or variables and pass them to other dependent libraries or executable modules. If you know how to solve the issue with taking address of virtual member, let me know in comment. I would really appreciate that. Thanks for today, see you soon, bye!